So, today we're looking at the converse of the Pythagorean Theorem. Bless you. So yesterday we just said, okay, it had to start off if it's a right triangle. And everything that we did yesterday, do you see how there was a right angle in every picture? There was a right angle. Or I somehow told you, today we're going to look at how can I tell if it's a right triangle if I'm given the side lengths. So that's called the converse of the Pythagorean theorem. Remember, converse is when we switch the hypothesis and the conclusion. So the converse says, if the square of the length of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So if c squared equals a squared plus b squared, you have a right triangle. I have these like things we'll get to. Oh no, I'll do it now. If I take, I'm gonna use these a lot today. Blue, purple, yellow. If I take these three side lengths and I put them together, I can create a right triangle. Blue, purple. Here's my right triangle. Because, and I know this is a right angle, first of all, I could check using a protractor, but you can kind of see it's a right angle. I can check, the blue is 12.24 centimeters long, 12.24 squared. The yellow, you guys can't see it, I can't see it, is 10 centimeters. And the purple is 7.07 centimeters. Oops. So if I take the two small ones, if I do Pythagorean theorem, they end up being the same. So this creates a right triangle. So if I give you three sides of the triangle and say, is it a right triangle, you're going to check the Pythagorean theorem. So the question is, what is A, what's B, what's C? Remember, C is always the longest side. So in A, 6 and 9 are A and B. That's interchangeable. But 3 root 13 is C. So we want to check. Is 6 squared plus 9 squared, is that equal to 3 root 13 squared? So I put an equal sign with a question mark on top because we're trying to ask ourselves, are they equal? What's 6 squared? What's 9 squared? Okay, here's the tricky part. Putting 3 root 13 in your calculator. Here's what you should not do. Either calculator, this is what you should not do. Because what the calculator is going to do is they're only going to square the root 13. And you get 39. That's not right. Everybody, when you do a problem like this, whenever you have a radical, use parentheses. Whether you have a graphing calculator or scientific calculator. So you want parentheses, 3 square root 13. Now, if you have a graphing calculator, you may have to press the over button to get out of the square root. Parentheses squared. Remember, the square root button is second and then the x squared. Okay, everybody always gets this problem wrong because they don't know how to put this in the calculator. So make sure you do parentheses and you get 1/17. And then we're going to check, is 36 plus 81 117? 117 is equal to 117. So yes, this is a right triangle. Okay, so the biggest part of this problem, when you see it on the quiz next Tuesday, is putting that in the calculator, right? But we'll try and do plenty of examples. Okay, if it's easier with just the numbers, it's nice, because in this one, we just got to check, are the two smaller sides, the square, equal to the big side? So is 16 squared plus 24 squared, is that equal to 29 squared? And you just check in your calculator. You can do this as one step if you want. 16 squared plus 24 squared. $832, $841. So they are not equal. Since they're not equal, you can say this is not a right triangle. Okay, so the Pythagorean theorem has to be true in order to create a right triangle. So there are other ways that you can classify a triangle just by its side. If the Pythagorean theorem is true, a squared plus b squared equals c squared, you have a right triangle. If c squared is less than a squared plus b squared, if c squared is less than a squared plus b squared, you have an acute triangle. So if I use my little thing here, if I take these three, this creates an acute triangle. Remember, acute means that all the angles are less than 90. So the green here is 8.66 squared. The purple is 7.07 squared. That should be less than 10, or more than 10 squared. Okay, my C is less than A plus B. I kind of always, because you're going to have to memorize this for your quiz, I always think, okay, C squared has to be smaller, which makes it an acute triangle because it's tiny. So that's kind of how I remember it. If C squared is bigger than A squared plus B squared, you have an obtuse triangle. If C squared is greater than A squared plus B squared. So, green, purple. Let me show you what that looks like. So here, my C squared is my C is much longer. C here is 14. So that squared should be bigger than my 8.66. So C squared is greater. Again, I always try to remember if C squared is longer, that means that this angle has to be bigger, so it's going to make an obtuse angle. So it depends on your hypotenuse. If your hypotenuse is equal, it's a right triangle. If it's smaller, it's an acute triangle. If it's bigger, it's an obtuse triangle. You see how that works? I like the visual. Okay. So, the only other thing we have to talk about is sometimes you even have to look, are these going to even make a triangle to begin with? Because sometimes I'm not going to give you a picture. I'm going to just give you three side lengths, and you got to say, does it even make a triangle? In order to make a triangle, A plus B just by itself has to be greater than C. Okay, in order for it to make a triangle. So let me show you. This red was my hypotenuse. Then I take a purple and an orange. Do you see how the purple and orange together are not as long as the red? So A plus B is not greater than C. If I try to make a triangle out of this, I can't. There's no way for me to connect the sides. So in order for that to work, you have to have the two smaller sides have to at least be longer, than the longest side in order to connect them. Okay, so sometimes it'll ask you, doesn't even make a triangle first, then what kind of triangle does it make? So this the only part that's tricky about this is you're not squaring it, you're just adding them up. So for example 2, can the segments with the following lengths form a triangle? If so, would it be acute, right, or obtuse? So first you want to check, is A plus B greater than C? That's your first step. And just go in order. C should always be your largest side. So here's 2.8 plus 3.2. Is that greater than 4.2? Or 2.8 plus 3.2 is 6. Is 6 greater than 4.2? Yes. So we can create a triangle. Now let's figure out what kind of triangle we're going to make. So now check the Pythagorean Theorem. I always do 2.8 squared, 3.2 squared. I kind of leave like an underscore, like a blank, with 4.2 squared. So you're going to have to write kind of small. We got to check, is this greater, less than, or equal to? So 2.8 squared, 3.2 squared is 18.08. $17.64. So 18.08 is greater, right? Which means my C is small, which means I have an acute triangle. Okay, because my C squared is smaller than my A squared plus B squared. Does that make sense? When you do these problems on the homework tonight or on a quiz or test, I need to see this work. If you just write the word acute, obtuse, or right, you're not going to get full credit. Okay, I got to see this work. So let's try B. First step is to look, is 6.1 plus 9.4, is that greater than 11.3? $15.5. Is that greater than 11.3? Yeah. Okay, so we're good. Now, let's do Pythagorean Theorem to figure out what kind of triangle it is. So 6.1 squared, 9.4 squared is what with 11.3 squared? This is 125.57. 127.69. So because this side is greater, our C squared is greater, this is an obtuse triangle. Since our C squared is greater. Okay, so there's going to be a whole bunch of formulas you're going to have to know for the quiz on Monday. Make sure you know the difference between acute and obtuse. Right's pretty easy. Because as long as they're equal, you're good. Can you use the side lengths of 50, 120, and 130 to verify that you have perpendicular lines? So the question, what do perpendicular lines make? They have to make a right angle. Right? Isn't that the definition of perpendicular? So we're kind of asking, can I create a triangle? Because then the lines will be perpendicular. So let's check. I'm not even going to check to make sure that they can make a triangle. Let's see, is 50 squared plus 120 squared, is that equal to 130 squared? If they are, then we have a right triangle, and then we have perpendicular lines. If they're not, we don't have perpendicular lines. So they're equal. So I have a right triangle. So we can say yes, they create perpendicular lines because they make a right triangle. Questions? Okay, I want you to try example 4 on your own. It's just like example 2. First, check, do they make a triangle? Because I can tell you right now, one of them is not a triangle. First, check, do they make a triangle? Then, tell me if you think they're acute, obtuse, or right. Okay, here's what you should get. A was a right triangle. 16 plus 30 is greater than 34. So you get, do the Pythagorean Theorem, you get a right triangle. B is not a triangle at all. 6 plus 2 root 3 is 9.46, which is smaller than 12. So B is not a triangle at all. So if it's not a triangle, just don't do it. And then C is a right triangle also. Now in your quiz, that'll be 2 separate questions. I'll just tell you to either tell me what kind of triangle it is or does it form a triangle. And I think on your homework tonight, it's 2 separate questions. So you won't have to necessarily do it together. Yeah. Okay, questions?